There is a sound that your house makes at night that it does not make during the day. Not a frightening sound, not a dramatic one. It is subtle, almost like breathing, the slight tick of a pipe cooling somewhere in the walls, the muffled compression of a floorboard that has settled the way old wood does after years of accommodating weight and weather. If there is wind outside, you might hear the low, far-off hum of it moving across a window frame. And underneath all of that, if the night is quiet enough, there is something else. A faint, almost imperceptible hum that might be the refrigerator or traffic 2 streets over, or just the sound of the world at its lowest volume, the sound it makes when almost everything has stopped. Most nights you do not notice any of this. Most nights you are asleep before you could notice it. But on the nights when you are lying here, still with your eyes not yet closed, with the day beginning to dissolve at the edges, you might become aware of it. This particular quality of nighttime silence, this specific texture of the dark, the way darkness at night in a familiar room is not frightening but restful. The way the outlines of the things around you, the door, the window, the shapes of furniture that you know so well you could draw them from memory, have become soft, approximate, friendly shapes in the dark rather than precise objects demanding anything from you. There is something about this hour that is genuinely different from all the others. Not just culturally, not just by convention, not just because we have decided that this is when rest happens. Physiologically different. The melatonin that your pineal gland has been releasing for the past hour or two has been doing its quiet work in the bloodstream, lowering core body temperature slightly, shifting cellular activity toward the rhythms of night, sending a signal to the whole organism that the active portion of the cycle is completing and the restorative portion is beginning. The light has changed too, or the absence of it has settled in. And the photoreceptors in your retinas that are sensitive not to color and shape but to the simple fact of illumination, the intrinsically photosensitive retinal ganglion cells that were discovered only in 2002, have stopped receiving the signals they were sending all day to the suprachiasmatic nucleus, the body's master clock, telling it, daylight still, continue operations at full capacity. Now those signals have quieted. The clock knows. The melatonin flows. The body begins to lower its core temperature toward the degree or two of cooling that marks the transition into sleep. And if you were to lie here with a sensitive thermometer on your wrist and another on your forehead, you would see the wrist warming and the forehead cooling, blood redistributing to the periphery, dissipating heat, because that dissipation of heat is one of the physiological conditions the brain requires before it will allow the deeper stages of sleep to begin. All of this is happening, right now, without your instruction. And something in you, something older than any word you have learned for it, reads that collection of information, the sounds, the temperature, the darkness, the quality of stillness, and draws a conclusion. Not a thought exactly, something quieter and more certain than a thought. Something that happens before your mind has had time to form it into language. Your nervous system, listening to the room, decides, this is all right. Here, in this particular arrangement of sensory information, nothing is wrong. Nothing requires attention. Nothing requires preparation. Nothing is approaching from the darkness that needs to be identified and evaluated before it reaches you. That is where we are beginning tonight, right there. In that moment when the body, before the mind has caught up to it, begins to settle. We are going to spend this evening exploring what that moment actually is. Not the idea of it. Not the poetry of it. Though there is real poetry in it, a kind of deeply earned beauty in the specific details of what your body does when it finally feels safe enough to let go. We are going to explore the science of it, the specific, detailed, beautifully complex biology of what is happening in the brain and the body when safety is registered. When the alarm that the nervous system runs continuously and quietly all day long begins to go quiet. When the signals traveling through ancient neural pathways that were in place long before there were human beings to carry them, start to carry a different message. All is well. Rest is possible. You can let go now, because here is the thing. The calm you feel on nights like this one, the loosening in your chest, the weight of the blanket that suddenly seems a little warmer, the breath that seems to come a little more easily without any effort from you. That is not nothing. It is the presence of something real and specific and profound, something your body is actively doing. There is a particular quality that comes to people who understand, at a physical level, what is happening to them in moments of calm. Not an intellectual understanding that sits in the mind like a fact, detached from experience, but a felt understanding. The kind that comes from knowing enough about the biology to recognize your own physiology as it moves through its states. The kind that allows you to notice the exhale lengthening and know in your body what that means. To feel the jaw unclench and understand what system just spoke. To feel the weight of the blanket more fully and recognize that your muscles have just released something they had been holding since morning. That is what we are here for tonight. Not information for its own sake. Understanding that deepens experience. Knowledge that makes the body more vivid to itself. So come further in. Let the room be the room it is. Let your body be wherever it is. Let your breath be whatever it is right now, without changing it or judging it or trying to improve it. And let us begin at the beginning, which is somewhere very deep inside you, somewhere ancient and watching and extraordinarily wise, and when it finally finds what it needs, capable of a peace that is not absence but fullness, not emptiness but the specific, real, living presence of everything that rest is supposed to be. Before we go anywhere else, we have to go somewhere quite specific. We have to go back a very long time. Not decades, not centuries, much further than that. Somewhere in the range of 500 million years, which is almost incomprehensible as a quantity of time, but which matters here because it is roughly the point at which nervous systems began to appear in creatures on this earth. The earliest nervous systems were simple by our current standards, loose networks of neurons that allowed a creature to sense something in the environment and respond to it. To feel something touch and move away from it. To detect a chemical gradient in the water and move toward it. Basic input, basic output. But already in those earliest arrangements of neural tissue, something important was happening. The nervous system was, from the very beginning, in the business of evaluation. Every signal that came in from the environment had to be processed. And the processing at its most fundamental level was always asking the same question. Is this something I need to respond to? Is this relevant? Is this a threat, a resource, or nothing worth attending to at all? That question, is this a threat, has remained at the center of nervous system function for 500 million years. Through every evolutionary branching, through every increase in complexity, through the development of spinal cords and hemispheres and prefrontal cortices and language, underneath all of it, the nervous system has never stopped asking that question. It asks it right now in your body, in the room you are in. It is asking it between one heartbeat and the next. What has changed over those 500 million years is not the question. It is the sophistication of the apparatus doing the asking and the sophistication of the answers the apparatus can generate. In those earliest creatures, the response to threat was simple and direct. Move away, contract, close off. In the most complex nervous systems that evolution has produced, in systems like yours, the response to threat is staggeringly elaborate. A cascade of hormonal signals, neural activity, vascular changes, metabolic shifts, attention reconfigurations, and eventually, if the evaluation finds no actual danger, an equally elaborate process of settling back down. But the settling back down is not automatic. It is not guaranteed. And it is not simple. Understanding why, really understanding the biological architecture of that settling, that return to calm, is one of the most illuminating things you can know about yourself. Because once you understand it, the experiences you have in safe moments start to feel different. More real somehow. More grounded. Not just feelings, but biology, specific, marvelous, life-sustaining biology. So let us follow that thread from the nervous system's first question all the way to the place you are in right now. Let us talk about ancient geography first. Not the geography of continents, though continents have drifted considerably in the 500 million years we are considering, but the geography of the brain itself. The human brain did not emerge fully formed. It was assembled in evolutionary time, layer by layer. The deepest and oldest structures are tucked at the base and center, where the brainstem meets the midbrain, and these structures govern the most fundamental functions. Breathing, heart rate, the basic regulation of arousal. These are structures we share in some form with reptiles, with fish, with animals whose lineage diverged from ours so long ago that there is almost no visible connection between us and them. Wrapped around and above those oldest structures are the limbic regions, the emotional brain, roughly speaking. These developed later in evolutionary history and are shared, in varying degrees, with other mammals. The limbic system is where memory is processed, where emotional responses are coordinated, where much of our social and relational life is organized. It is less ancient than the brainstem, but still very old. Still running programs that were written long before any human civilization existed. And then, above and around all of that, is the newest addition, the cerebral cortex, the vast folded sheet of gray matter that is responsible for language, reasoning, planning, imagination, and all the things we typically associate with human intelligence. The cortex is extraordinary. It is the structure that allows you to think about thinking, to form concepts about concepts, to contemplate your own contemplation. It is, in some sense, what makes us who we are as a species. But here is something important to hold in your mind. When these three layers of brain, the old, the middle, and the new, are faced with a potential threat, they do not deliberate together as equals. There is a hierarchy. The older systems have priority. The brainstem and limbic structures can commandeer the body's resources before the cortex has had a chance to weigh in. This is why fear can feel so physical, so immediate, so overwhelming. Because the emotional and regulatory systems that generate it are faster and more directly connected to the body's machinery than the thinking brain that might eventually try to talk them down. This hierarchy was adaptive. In a genuinely dangerous situation, the body cannot wait for the cortex to finish deliberating. It needs to act. And so evolution built in a fast track, threat detection first, careful reasoning second, if at all. By the time you are aware that something is frightening, your heart is already accelerating, Your muscles are already priming. Your digestive system is already suspending its operations. The body has been acting for several hundred milliseconds before consciousness arrived at the scene. This means something for our story. It means that the path to feeling safe is not primarily through reasoning. You cannot simply think your way into the physiological state of safety, any more than you can think your way into sleep. The systems that govern safety operate below and prior to the thinking mind. They respond to inputs the thinking mind may not even be aware of. They make their assessments based on information that arrives through channels that bypass conscious processing entirely. To understand safety, then, is to understand what those older, deeper systems are listening for, and what it means when they find it. Now we can meet the amygdala properly. The amygdala is one of the most studied structures in all of neuroscience. It sits deep within the temporal lobe, roughly behind and above each ear, one on each side of the brain. In a full human brain, it is approximately the size and shape of an almond, which is, as it happens, exactly what amygdala means in Latin from the Greek amygdale, almond. Two small, almond-shaped clusters of neurons, and yet the influence they exert on the whole of a human life is entirely disproportionate to their size. For most of the 20th century, neuroscience thought of the amygdala primarily as the fear center, the place where fear lives, where it is generated and stored and expressed. This view was supported by a wealth of experimental evidence. Damage to the amygdala in humans produced striking changes in the ability to process fearful facial expressions, in the capacity to learn from threatening events, in the experience of fear itself. People with amygdala damage would sometimes walk into situations that most people would recognize as dangerous without any apparent concern. Not because they were brave, but because the part of the brain that would normally generate the feeling of concern was not functioning normally. We have since come to understand that the amygdala's role is considerably more nuanced. It is not simply a fear machine. More precisely, it is what neuroscientists now describe as a salience detector, a structure that marks things as important, whether that importance is threatening or rewarding or surprising or emotionally significant in other ways. It processes emotional meaning across a broad spectrum, but its special sensitivity to threat, its ability to detect potential danger rapidly, reliably, and below the level of conscious awareness, remains one of the most important things about it. The speed of the amygdala's threat detection is remarkable. In studies using brain imaging alongside carefully timed presentations of threatening images, researchers found that the amygdala responds to a frightening face in as little as 12 to 15 milliseconds, far faster than any conscious recognition of what has been seen. In other studies, threatening images were presented subliminally, flashed so briefly that subjects had no conscious awareness of seeing them at all, and yet their amygdalae showed clear activation. The neural signal of threat was registered and processed without ever reaching the threshold of conscious experience. Think about what that means for ordinary life. When you walk into a room and immediately feel uneasy, without being able to say why. When you meet someone and something feels off before they have said or done anything you could point to, when a place that should feel familiar suddenly doesn't quite. These experiences are not irrational. They are not imagination. They are the amygdala reporting on information it has already processed, information that arrived through sensory channels and was evaluated against a library of learned and inherited associations before your thinking brain had the opportunity to form a single sentence about it. This library is built through experience. The amygdala is deeply involved in a process called fear conditioning, the linking of neutral stimuli to threatening experiences in memory. This is why certain sounds, certain smells, certain configurations of light or sound or social dynamic can produce a stress response even in the complete absence of any objective danger. The amygdala learned at some point in your history that this particular kind of sensory input goes with danger. And now it reports accordingly, even when the original danger is nowhere present. This learning is not always consciously accessible. Some of it happened in early childhood, before the explicit memory system was fully developed, before there were words to form around the experiences. Some of it happened quickly in single intense experiences, the kind of learning that happens when something truly frightening occurs, where the association is encoded so strongly that it persists for decades. Some of it is ancestrally inherited, built into the structure of the amygdala itself across evolutionary time. The readiness to find certain patterns threatening without ever having learned to, because the patterns that correspond to snakes or spiders or sudden loud noises or angry faces or eyes watching from darkness have been reliably predictive of danger for so long that evolution has pre-wired a degree of sensitivity to them. All of this is the amygdala doing its job. And its job is not to make you afraid. Its job is to keep you alive by making sure you notice what matters. But when the amygdala quiets, when it has processed the available information and found nothing that meets its criteria for alarm, what happens is profound. Not just in the amygdala itself, but rippling outward through everything it connects to, which is, in fact, nearly everything. The amygdala has extensive connections to the brainstem, to the hypothalamus, to the prefrontal cortex, to the autonomic nervous system that regulates the body's organs. When it is activated, it sets in motion a cascade of changes across all of those systems. And when it settles, when it quiets, that cascade reverses. Not all at once, but gradually, like a wave retreating. The shoulders drop, the jaw unclenches, the muscles of the face soften. The breath, which had been held slightly shallower, deepens. The stomach, which had been holding a subtle tension, releases. None of these are dramatic changes, but they are real. They are the body responding to a shift in the signal it is receiving from one of its most important evaluators. The amygdala has looked at the information and concluded, nothing here requires our attention right now. You are safe. To understand how the amygdala communicates that conclusion to the body, how the feeling of safety propagates from that small almond-shaped cluster of neurons outward through the whole of you, we need to meet the autonomic nervous system. The autonomic nervous system is, as its name suggests, the part of the nervous system that operates autonomously, automatically, without your conscious participation or control. It governs the heart, the lungs, the digestive system, the blood vessels, the glands, all the organs whose function you do not have to think about. It is working right now as you read this, adjusting 1,000 different variables across your body in real time, maintaining the conditions necessary for you to be alive without requiring anything from you in terms of attention or intention. The autonomic nervous system is traditionally divided into two branches that are often described as opposites: the sympathetic and the parasympathetic. These two branches work in a dynamic balance, each influencing and modulating the other, each taking a different kind of precedence in different situations. The sympathetic branch is associated with mobilization, with the preparation of the body for action, particularly the kind of urgent action required by threat. The parasympathetic branch is associated with the opposite condition: restoration, maintenance, digestion, repair, and rest. The sympathetic nervous system's response to threat is comprehensive and precise. When the amygdala signals danger, a message travels down through the brainstem to the spinal cord, and from there out to every organ in the body simultaneously. The adrenal glands, which sit just above the kidneys, receive the signal and release adrenaline, also called epinephrine, directly into the bloodstream. Adrenaline is a fast, powerful hormone. Within seconds of its release, it is producing changes throughout the body. The heart accelerates. Blood pressure rises. The blood vessels that supply the large muscles of the arms and legs dilate, allowing more blood flow to those muscles. Simultaneously, the blood vessels that supply the digestive organs constrict, redirecting blood away from functions that are not immediately necessary. The liver releases glucose into the bloodstream, providing quick energy. The lungs expand their capacity. Breathing becomes faster and more shallow, prioritizing oxygen exchange. The pupils dilate, admitting more light. Even sweating begins, partly to cool the body in anticipation of physical exertion, and partly because sweat alters the texture of the skin in ways that are thought to improve grip. All of this happens in seconds. It is the body reorganizing itself from a state of ordinary maintenance into a state of emergency readiness. For a genuinely dangerous situation, it is exactly right. It is the system doing precisely what it evolved to do. But what happens when there is no genuine danger? What happens when the amygdala sends its alert based on something that feels threatening but is not? The abstract worry about a problem that has no physical solution, the memory of something frightening, the anticipation of something that might go wrong. All the things that occupy a modern human nervous system that did not exist as possibilities for the organisms in whose bodies this system evolved. What happens is that the sympathetic response still activates. The heart still accelerates. The blood still shifts. The hormones still release. The body still prepares itself. And then, when the threat turns out to have been abstract, when there is nothing to run from, nothing to fight, nowhere for all that mobilized energy to go, the body has to absorb it somehow. It has to find its way back to baseline. That return to baseline is not passive. It is not simply the stopping of the sympathetic response. It is the active engagement of the parasympathetic branch. It requires a specific signal. A signal that all is well, that the threat has passed or was never real, that the body can now turn its attention back to the quieter work of living. And that signal is carried primarily by one of the most remarkable structures in the human body, the vagus nerve. Let us slow down here and spend some real time with the vagus nerve, because it deserves it. It is, in many ways, the nerve of this whole story. The vagus nerve is the 10th cranial nerve, the 10th in the series of nerves that emerge directly from the brain, rather than from the spinal cord. It originates in a region of the brainstem called the medulla oblongata, which is the lowest part of the brain, sitting just above the point where the brain transitions into the spinal cord. From that origin point in the medulla, the vagus nerve descends through the neck, passing through the jugular foramen, a small opening in the base of the skull, and then continuing downward into the chest, where it branches to reach the heart and the lungs, and from there into the abdomen, where it reaches the liver, the stomach, the spleen, the kidneys, and the small intestine, with signals reaching as far as the transverse colon. The name vagus comes from the Latin word for wandering. Nervus vagus, the wandering nerve. And it really does wander in a way that no other cranial nerve quite replicates. It is the longest of all 12 cranial nerves. covers more territory. It reaches more organs. It is involved in more physiological processes. And it is, in terms of our story tonight, the primary physical pathway through which the experience of safety propagates through the body. The vagus nerve carries what are called parasympathetic fibers, fibers that carry the calming, restorative signals of the parasympathetic nervous system to the organs. When the vagus nerve is active and its parasympathetic signals are flowing, the heart receives a message. Slow down. The lungs receive a message. Deepen the breath. Let it become more regular. The gut receives a message. Resume your work. The inflammation response receives a message through what is called the inflammatory reflex. Stand down. There is no emergency here. But here is one of the most astonishing and underappreciated facts about the vagus nerve, and it is a fact that fundamentally changes how we think about the relationship between the brain and the body. The vast majority of the fibers in the vagus nerve, approximately 80 to 90%, depending on which research you consult, are afferent fibers. Afferent means they carry information toward the brain, not away from it. They carry information from the body up to the brain, not instructions from the brain down to the body. The vagus nerve is primarily a sensory nerve. It is the body speaking to the brain. The heart reports its rate and rhythm upward through the vagus nerve. The lungs report the depth and pace of breathing. The stomach reports its tension or relaxation, its fullness or emptiness. The gut reports the state of its contents, the activity of its microbiome, the quality of the chemical environment within it. All of this information travels constantly, continuously upward through the vagus nerve to the brainstem and from there to higher brain centers, where it informs directly physiologically below any conscious processing, the brain's understanding of the current state of the body. This means that the state of your body is not simply a consequence of what your brain decides. It is also a cause of what your brain decides. When the heart is racing and the breath is shallow and the gut is tense, the vagus nerve carries that information upward and the brain receives it as a report. The body is in a state of activation. Something may be wrong. The brain, receiving that report, is more likely to interpret ambiguous information as threatening, more likely to prime threat detection systems, more likely to maintain vigilance. And when the heart is slow and the breath is deep and the gut is relaxed, the vagus nerve carries that information upward and the brain receives it differently. The body is in a state of rest. Things are well. The brain, receiving that report, is more likely to interpret ambiguous information as benign, more likely to allow the threat detection systems to quiet, more likely to permit the deeper stages of rest. This is the biological basis of what many people experience intuitively, that when we slow the breath, when we soften the body, when we deliberately create the physical conditions of rest, the mind follows. Not always immediately, not always completely, but in a real, measurable, neurologically grounded sense, the body leads and the brain reads. The vagus nerve also contains what are called myelinated fibers. Fibers wrapped in a fatty coating called myelin that allows them to conduct signals much more rapidly than unmyelinated fibers. The distinction matters because, according to Stephen Porges' polyvagal theory, a framework we will return to in detail, it is specifically the myelinated vagal fibers, arising from a structure called the nucleus ambiguus in the ventral portion of the brainstem, that are responsible for the most sophisticated and specifically human aspect of safety: the capacity for calm social engagement. These fibers are connected not only to the heart and lungs, but to the muscles of the face, the throat, and the middle ear. The same neural circuitry that puts the brakes on the heart also controls the muscles that allow a face to be read, that modulate the voice into the frequencies of warmth and safety, that tune the middle ear to the range of the human voice. When you feel safe in the presence of another person, when their tone of voice, their facial expressions, and their overall demeanor communicate that they are not a threat, the vagus nerve is part of what is registering that safety. It is part of what allows your own face to soften in response, your own voice to become warmer, your own nervous system to settle into the particular quality of ease that comes from being genuinely, bodily, physiologically seen as safe. This is not metaphor. This is anatomy. The heart rate variability we mentioned earlier, the slight, rhythmic fluctuation in the time between heartbeats, where the interval is slightly shorter when you breathe in and slightly longer when you breathe out, is directly regulated by the vagus nerve. And this variability, far from being a random fluctuation, is a meaningful signal of health. A heart that beats with perfectly regular intervals, with no variation from beat to beat, is not a sign of a calm, well-regulated nervous system. It is actually a sign of a system that has lost its flexibility, its capacity to respond dynamically to changing conditions. The slight variability produced by vagal activity is the signature of a nervous system that is both at rest and ready, settled, but not rigid. Heart rate variability, or HRV, has become one of the most important non-invasive measures in cardiovascular medicine and neuroscience. Higher HRV is associated with better emotional regulation, lower risk of cardiovascular disease, greater resilience in the face of stress, better sleep quality, and more effective immune function. Lower HRV is associated with the opposite, with conditions of chronic stress, anxiety, depression, poor sleep, and increased cardiovascular risk. And HRV can be measured, tracked, and in some degree improved through practices that directly engage the vagus nerve. Slow, rhythmic breathing, particularly breathing at a pace that synchronizes with the natural oscillation of the cardiovascular system. Social engagement with people whose presence is genuinely calming, gentle rhythmic movement, singing or humming or any voice sound that requires the sustained involvement of the throat muscles. Each of these practices is, in a very direct sense, speaking to the vagus nerve. They are providing it with inputs that it reads as consistent with safety, as conditions that allow it to carry its calming message more fully, more consistently, down to the heart and the gut and the lungs and back up to the brain. The vagus nerve is sometimes described as the body's superhighway to calm. It is also the longest conversation your body is having with itself. And when that conversation goes well, when the body and brain are exchanging the information of rest, each confirming the other's signal, something settles in you that is not only one thing, but everything at once. The breath, the heart, the gut, the face, the mind, all of it gently, silently falling into agreement. Here, for now, all is well. Now there is a name for something we have been circling around, and it is worth taking time to introduce it properly, because it is one of the most important concepts in modern neuroscience of safety. The name is neuroception, and it belongs to Stephen Porges. Stephen Porges has spent much of his career studying the autonomic nervous system, specifically its role in the experience of safety and threat, and the way those experiences ripple through the whole of human psychology and physiology. In 1994, he introduced polyvagal theory, a framework for understanding the autonomic nervous system as not simply two branches, sympathetic and parasympathetic, but three distinct response systems organized in an evolutionary hierarchy. And in 2004, he introduced a concept that has proven to be enormously influential not only in neuroscience but in psychology, trauma therapy, education, and the study of human relationships. He called it neuroception. The word itself is constructed deliberately. Perception is what happens when you consciously notice something, when you look at a tree and see a tree, when you hear a sound and recognize it as music. Neuroception is something different. It is a process by which the nervous system evaluates the environment for cues of safety or danger below the threshold of conscious awareness. Before thought, before attention, before language, your nervous system is reading the room in ways that your conscious mind will never have full access to, and drawing conclusions that will shape your experience from the inside out without ever asking your opinion. Porges describes neuroception as the mechanism by which our neural circuits distinguish whether situations or people are safe, dangerous, or life-threatening. It operates through the detection of a specific set of cues, some of which are in the external environment, and some of which are in the state of our own bodies. Environmental cues of safety include slow, rhythmic, predictable sounds. The sound of the human voice in its low, warm, prosodic register. Faces with open, neutral, readable expressions. Predictable, non-jerky movement. Soft, even light. Ambient temperature within a comfortable range. Enclosed or bounded space with visible access to exit. The presence of calm, known people. Environmental cues of threat include sudden, unpredictable sounds. Voices with high, sharp, rapid prosody or monotone flatness. Faces that are angry, hidden, or expressionless in ways that feel unreadable. Fast, chaotic, or unexpected movement. Harsh or flickering light. Extreme temperatures. The absence of other humans or the presence of humans whose state seems highly activated. And here is what is remarkable about neuroception. It is happening all the time, even especially below the level of awareness. Your nervous system is reading every room you walk into before you have finished deciding whether you like it. It is reading every person you meet before you have finished forming your first impression. It is reading your own body, the state of your heartbeat, the quality of your breathing, the tension or relaxation in your muscles, and using that information to update its assessment of the overall situation continuously. This is why environments matter. Not just philosophically, not just aesthetically, but physiologically. The environment you are in right now is being read by your nervous system, and that reading is influencing your state at this very moment. The temperature of the room. The quality of whatever light is or isn't present. The sounds, whether they are predictable and soft or sudden and variable. Whether there are other people nearby, and what state those people seem to be in. All of this is input. All of it is being processed. And the output of that processing is your nervous system's current assessment of safety, which is, right now, gradually moving in the direction of rest. Porges also made an important distinction between two types of situations where neuroception fails. The first is when the system detects threat where none exists, when the nervous system reads safety cues as dangerous because of past experiences that have shaped its threat detection calibration. People who have been through genuinely frightening experiences, particularly early in life, can develop a neuroceptive system that is, in a sense, too sensitive, that finds threat in situations that are objectively safe, because its library of threat-associated cues includes things that are common and ordinary. The hypervigilance that follows trauma is not a character flaw. It is a neuroceptive system doing its job, but doing it with information calibrated to an environment that no longer exists. The second failure mode is when the system fails to detect danger that is actually present. When neuroception reads a genuinely dangerous situation as safe, because the cues of danger have been masked or distorted. This is relevant in certain interpersonal contexts, and it underscores why the system, for all its sophistication, is not infallible. But for our purposes tonight, for the particular journey we are on, here in this room, in this night, what matters is the other direction. The moment when neuroception reads the available information and concludes, safe. The moment when the evaluation comes back positive. Because when it does, when the nervous system, through this preconscious, prelinguistic, body-based assessment, decides that the present situation does not require any defensive response, the effect on the whole organism is profound. The parasympathetic system can engage fully. The vagus nerve can carry its calming signal without interference. The amygdala can quiet. The body can begin to shift from the physiology of vigilance to the physiology of rest. And all of that beautiful, complex, ancient biological transition begins not with a thought but with a neuroception. A wordless conclusion drawn by the deep nervous system from the accumulated information of the present moment. Here now, this is safe. There is a further dimension of polyvagal theory that deserves attention because it adds important texture to what it means to feel safe. And it introduces a third state of the nervous system that sits alongside fight or flight and rest and digest. In the traditional model of the autonomic nervous system, the two branches, sympathetic and parasympathetic, represent a simple binary, mobilized or settled. But Porges, drawing on evolutionary neuroscience and comparative anatomy across vertebrate species, proposed that the parasympathetic branch of the vagus nerve has not one but two distinct subsystems, each with a different evolutionary history and a different behavioral function. The older of the two vagal subsystems is called the dorsal vagal complex. The dorsal vagus originates from an area of the brainstem called the dorsal motor nucleus, and it is present in all vertebrates, even in very primitive ones. In the face of extreme, inescapable threat that cannot be responded to by fighting or fleeing because it is simply too overwhelming or because escape is impossible, the dorsal vagal complex can produce a dramatic shutdown of the body. Heart rate plummets. Blood pressure drops. The body becomes still and unresponsive. This is what we recognize as the freeze response or the collapse response. What happens to a mouse caught by a cat, or what can happen in humans in the most extreme traumatic circumstances. A kind of physiological shutting down when the system has determined that neither fight nor flight is a viable option. The dorsal vagal shutdown is not the same as rest. It is not the parasympathetic state of safety. It is a different, much older, much more drastic response. A kind of emergency conservation mode in which the nervous system does the minimum necessary to keep the organism alive while it waits for conditions to change. In mild forms, this state can manifest as the heaviness and fatigue of depression, or the numbness and disconnection of dissociation. A low-energy, shut-down quality that is very different from the ease and warmth of genuine calm. The newer of the two vagal subsystems, newer in evolutionary terms, present only in mammals, is called the ventral vagal complex. The ventral vagus originates from the nucleus ambiguus in the front portion of the brainstem, and it is this system that governs what Porges calls the social engagement system. When the ventral vagal complex is active, not only are the calming parasympathetic brakes applied to the heart and lungs, but the muscles of the face, the throat, and the middle ear are also regulated in a coordinated way. The face becomes more expressive and readable. The voice takes on warmth and prosody, the musical quality that makes a voice soothing rather than flat or grating. The muscles of the middle ear tune themselves to the frequency range of the human voice, making it easier to distinguish speech from background noise. This is the system that is active when you feel genuinely safe in the company of another person. When you are at ease in a conversation, when you are truly listening, when you are not monitoring for threat but simply present, this is ventral vagal territory. And it is, in Porges' framework, the most evolved and the most specifically human of the three states, because it requires not just the absence of danger, but the presence of genuine safety, and, ideally, the presence of other people whose nervous systems are also in a ventral vagal state, co-regulating each other in the particular way that calm, connected humans do. The three states in this framework form a hierarchy. The ventral vagal state, safe, connected, at ease, is the state from which full human living is possible. Below it, if safety is disrupted, the nervous system drops to the sympathetic state, mobilized, activated, ready to fight or flee. And if the threat is overwhelming and escape is impossible, the system drops further still to the dorsal vagal shutdown. The nervous system moves down this hierarchy when it needs to, and climbs back up it when conditions permit. The direction of climb is important. You cannot jump from a dorsal vagal shutdown directly back to the ventral vagal calm. You have to pass through the sympathetic activation on the way up, which is why trauma recovery, when it involves very shut down states, so often requires a period of what looks like agitation or anxiety before it can reach genuine peace. The nervous system has to mobilize before it can settle. It has to come back into activation before it can ease all the way into rest. But for most of us, most of the time, the relevant movement is the one from sympathetic activation, the low-level hum of daily stress, back up to ventral vagal calm. And that movement is the one we are making right now, here in this quiet. The nervous system, finding nothing that requires its defensive apparatus, beginning its gradual climb back toward the state it evolved for, safe, connected, at ease. Now let us go somewhere very particular. Let us go into the body itself and let us follow what safety actually feels like. Not as a metaphor, not as an emotion, but as a physical event happening in specific tissues and structures with specific consequences for each of them. We will begin with the breath. Your breathing at this moment is happening without your instruction. The respiratory centers in the brainstem are managing it, monitoring carbon dioxide levels in the blood, adjusting the rate and depth of each breath automatically. But the quality of breathing, its depth, its rhythm, the ratio of inhale to exhale, where in the body it moves, these are influenced by the state of the autonomic nervous system. In a state of sympathetic activation, breathing tends to become faster, shallower, and higher in the chest. The diaphragm, the large dome-shaped muscle below the lungs that is the primary driver of breathing, does not descend as fully on each inhale. Less lung volume is used. The breath has a slightly urgent quality to it, even if you do not consciously notice. In a state of parasympathetic dominance, breathing does something different. It slows, it deepens. The diaphragm descends more fully on each inhale, creating a larger negative pressure in the chest cavity, drawing air down into the lower lobes of the lungs where there is more surface area for gas exchange. The belly rises and falls visibly as the diaphragm does its work. And the exhale, this is important, becomes slightly longer than the inhale. That lengthening of the exhale is not incidental. It is physiologically significant. The phase of breathing and the activity of the vagus nerve are deeply linked. During inhalation, the stretch receptors in the lungs send signals that momentarily inhibit vagal activity, causing a slight increase in heart rate. During exhalation, vagal activity increases, slowing the heart. This is the mechanism behind what is called respiratory sinus arrhythmia, the normal, healthy fluctuation in heart rate with breathing, and it is directly mediated by the vagus nerve. A longer exhale means more time during which the vagus nerve is fully active, more time during which its calming signal is being sent to the heart. This is why the long, slow exhale feels so specifically restorative. Not just psychologically, but neurologically. The body is using the mechanics of breath to activate its own calming system. When you let an exhale go long and complete, when you empty the lungs more fully before beginning the next inhale, you are giving the vagus nerve more runway. You are, in a direct physical sense, deepening the signal of safety. As the breath changes in safety, so does the heart. The resting heart rate, the rate at which the heart beats when the body is genuinely at rest, for a healthy adult is somewhere between 60 and 100 beats per minute. In a state of anxiety or stress, even mild and chronic, the resting heart rate tends to sit toward the higher end of that range or above it. In a state of genuine parasympathetic dominance, in the kind of deep calm that comes from feeling truly safe, the heart rate settles toward the lower end and may drop below 60 beats per minute in people who regularly experience that kind of rest. But the number is not the only thing that changes. The rhythm changes too. As we discussed, heart rate variability, the beat-to-beat variation in the timing of heartbeats, increases in parasympathetic states. That increase is a sign of the vagus nerve actively modulating the heart, applying its gentle braking influence on a moment-by-moment basis as the breathing cycle changes the demand. The heart, in genuine safety, does not beat mechanically. It breathes in a sense, its rhythm expanding and contracting with each breath, in a dance with the lungs and the vagus nerve that produces the signature of health. Blood pressure responds to safety in a related way. The blood vessels throughout the body, which in sympathetic states may be slightly constricted, tighten to redirect blood flow and increase pressure for action, relax. They dilate slightly. The resistance to blood flow decreases, and the heart's work of pumping becomes fractionally easier. The warmth you might feel spreading through your body in moments of genuine deep relaxation, particularly through the hands and feet, which are often the last places blood flows freely when the body is in any degree of stress, is the warmth of those blood vessels finally opening. Skin conductance is another marker of nervous system state that changes with safety. The skin, particularly on the palms and fingertips, contains sweat glands that are regulated by the sympathetic nervous system. In any state of even mild activation, even a state you might not consciously register as stress, these glands produce a slight increase in moisture that changes the electrical conductivity of the skin. This is what polygraphs measure, among other things, and it is the basis of biofeedback measurements of arousal. In genuine parasympathetic rest, skin conductance drops. The skin becomes, in a physiologically real sense, quieter. The muscles follow. Chronic sympathetic activation produces what is called increased baseline muscle tone, a slight, persistent tension in the muscles even when they are not actively being used. You may not notice this tension because it is your normal. It is the background level of readiness your body maintains when it is spending time in a vigilant state. But when the parasympathetic system takes over, when safety is genuinely registered, that baseline tension releases. Muscles that have been holding themselves a little tight, a little ready, soften. You can sometimes feel this as a kind of heaviness. The body, releasing its held tension, suddenly feels more substantial, more gravity-laden, as if the weight you always had is only now being fully felt because you are no longer unconsciously bracing against it. The shoulders drop. The back, which may have been held just slightly rigid, softens against whatever is supporting it. The hands, which tend to maintain a slight curl in states of arousal, open. Even the tongue, which many people hold pressed against the roof of the mouth or slightly forward in the jaw, drops to the floor of the mouth and relaxes. The face changes in ways that are surprisingly specific. The muscles around the eyes, orbicularis oculi, relax, so that the eyes become slightly softer in their setting. The muscles of the forehead smooth. The corrugator supercilii, the small muscle that creates a frown by drawing the eyebrows inward and downward, releases. The masseter, the powerful jaw muscle that is one of the primary sites of tension in anxious states, unclenches. The platysma, the thin muscle that runs across the front of the neck and can produce a slightly strained or stretched look in high-tension states, relaxes. Each of these changes is small. Together, they produce what we recognize as a calm face. A face that, importantly, is legible to the nervous systems of other people because it is sending the same signals that the ventral vagal system evolved to broadcast. I am not a threat. You are safe with me. The digestive system, as we noted earlier, deserves particular attention as a gauge of nervous system state. The entire gastrointestinal tract, from the esophagus to the colon, is regulated by the autonomic nervous system, and it is exquisitely sensitive to shifts between sympathetic and parasympathetic dominance. The gut contains, as neurologists have documented, somewhere between 100 million and 500 million neurons, a network so complex and so capable of independent function that it is often called the enteric nervous system or the second brain. This second brain is connected to the first brain primarily through the vagus nerve, and the conversation between them runs in both directions. The brain can signal the gut to slow down or speed up, but the gut is also constantly signaling back, sending information about its current state, the degree of fullness, the quality of muscular tension, the chemical composition of its contents, the status of its resident bacterial population, all of which influences the brain's interpretation of the current situation. When the sympathetic system activates, blood flow to the gut is diverted. Digestive enzyme secretion slows. The muscular activity that moves food through the intestinal tract, called peristalsis, becomes irregular or suspended. The gut microbiome, which is deeply sensitive to the hormonal environment of the body, shifts its composition in ways that reflect the state of stress the host organism is experiencing. Researchers have found that chronic stress can alter the diversity and health of the gut microbiome within days, with downstream effects on immunity, mood, and the gut's own capacity to regulate itself. When the parasympathetic system takes over, when vagal activity increases and the safety signal propagates down to the gut, the reversal of all of this begins. Blood returns to the intestinal walls. Secretion resumes. The smooth muscles of the gut begin their coordinated rhythmic contractions. The microbiome finds conditions more hospitable to the bacterial communities that support digestion and produce neurotransmitters, particularly serotonin, of which approximately 90% is produced not in the brain but in the gut. The entire interior of the body becomes, in a word, busy. Quietly, patiently, productively busy, doing the deep work that it saves for safety. There is something I find quietly remarkable about this. When we are safe, the body immediately turns its attention to feeding itself. Not in any dramatic way, not in a way that is visible from the outside, but in the most fundamental sense possible. When given the signal that the emergency is over, the body's first priority is nourishment. Picks up exactly where it left off. It resumes the business of extracting what it needs from what it has been given. The body, told it is safe, begins to eat. And somewhere in all of this, in the softened muscles and the slow heart and the deep breath and the busy gut and the released jaw and the softened eyes, the chemistry of the brain shifts too. Cortisol, the primary stress hormone, which had been elevated to varying degrees by whatever level of sympathetic activation the body was carrying, begins to decline. The hypothalamic pituitary adrenal axis, the hormonal cascade through which the brain signals the adrenal glands to produce cortisol, quiets. The adrenal glands reduce their output. The bloodstream clears. Cortisol is not simply a villain in this story. In appropriate quantities and at appropriate times, cortisol is essential. It mobilizes energy, modulates the immune response, maintains blood pressure under stress, and plays a role in consolidating certain kinds of memory. But chronic elevation of cortisol, the kind that comes from sustained or frequently activated sympathetic states, is genuinely damaging over time. It impairs immune function by reducing the production and activity of T cells and natural killer cells. It disrupts sleep architecture, reducing the proportion of time spent in deep, slow-wave sleep. It can contribute to the death of neurons in the hippocampus, the brain region primarily responsible for the formation of new memories, which is one of the reasons that chronic stress can impair learning and memory. It accelerates what researchers have called immunosenescence, the aging of the immune system, in ways that can shorten telomere length and advance the biological aging of cells. When cortisol levels drop, when the HPA axis quiets in the signal of safety, all of this begins to reverse. Not overnight, not immediately, but consistently, cumulatively over time. The immune system recovers its range. The hippocampus, protected now from the toxic effects of excess cortisol, does its work more effectively. Sleep deepens. Memory consolidates more cleanly. The body, freed from the metabolic cost of sustained readiness, redistributes its resources toward the longer-term investments of health and resilience. And alongside this hormonal quieting, another chemistry is beginning. Oxytocin, synthesized in the hypothalamus and released into the bloodstream through the pituitary gland, begins to rise. Oxytocin is often called the bonding hormone or sometimes the love hormone or more recently the safety molecule. It is released during physical warmth and gentle touch, during eye contact with someone trusted, during the particular quality of being truly seen by another person, during moments of genuine connection, whether between parent and child or partners or friends, or even between a person and a beloved animal. Oxytocin does something remarkable to the amygdala. It quiets it. Research has shown that intranasal administration of oxytocin reduces amygdala response to threatening stimuli, making the whole system less reactive, less hair-trigger, more able to register safety even in situations where there is ambiguity. It is as though oxytocin recalibrates the threat detection system toward a more generous assessment of the world. It makes the brain more likely to interpret an ambiguous expression as friendly, more likely to trust, more likely to move toward connection rather than away from it. This creates a loop. Safety allows oxytocin to rise. Oxytocin quiets the amygdala. A quieter amygdala allows the neuroceptive system to register even more safety. More safety allows more oxytocin. The nervous system, given the conditions it needs, builds its own momentum toward calm. You are in the middle of that loop right now. We have spent a long time in the body. Let us spend some time in time itself. In deep time, in evolutionary time, because understanding why the nervous system works this way requires understanding when it was built and what it was built for. Every animal that sleeps faces the same fundamental problem. Sleep is dangerous. This statement might seem counterintuitive. Sleep feels safe. But from the perspective of evolutionary survival, sleep is one of the most vulnerable states an organism can be in. During sleep, responsiveness to the environment drops dramatically. The ability to detect and respond to approaching predators is greatly reduced. The capacity for coordinated action, to run, to fight, to call for help, is suspended. For an animal living in an environment with genuine predators, sleep is a calculated risk. The benefits it provides must outweigh the costs of being temporarily defenseless. Research across mammalian species has consistently found a relationship between predation risk and sleep duration. Animals that are more at risk from predators sleep less, on average, than animals that are able to secure safe sleeping locations. Mammals that sleep in trees, where ground predators cannot easily reach them, sleep more than mammals that sleep on the ground. Larger mammals, which have fewer natural predators, generally sleep less than smaller mammals, which have more. The little brown bat sleeps approximately 20 hours a day, partly because its prey is only available for a few hours each night and it has nothing useful to do for the rest of the time, and partly because in daylight in a cave, it is largely protected from the aerial predators that would threaten it if it were out. Human beings have one of the shortest sleep durations of any primate, averaging around 7 hours, compared to 9.5 for chimpanzees, 13 for cotton-top tamarins, and 17 for three-striped night monkeys. This is the human sleep paradox. Despite having some of the most cognitively demanding brains in the animal kingdom, and despite requiring extensive sleep to maintain those brains, humans sleep less than their primate relatives. Evolutionary anthropologists David Sampson and Charles Nunn, who have studied this paradox extensively, propose that human sleep evolved to be more intense and more efficient partly as a response to predation risk associated with sleeping on the ground, which humans do, unlike our tree-sleeping primate relatives, and partly because of the enormous competing benefits of remaining awake. Learning, social interaction, tool-making, forming alliances, and the many other activities that characterize human social life and that natural selection may have favored extending beyond daylight hours. The safety of the sleeping group was likely critical. Archaeological and anthropological evidence suggests that early humans slept communally, in groups around fires that provided warmth and deterred predators, with variation in individual sleep schedules that meant there was likely always someone at a lighter stage of sleep, capable of responding to disturbances. Some researchers have proposed what is called the social sleep hypothesis. The idea that the evolution of human sleep is, at its core, a story about safety in numbers, about the way a group of sleeping bodies around a fire created a collective security that allowed each individual to descend more deeply into the restorative stages of sleep than any one of them could have managed alone. The fire, the enclosed space, the sound of other breathing bodies, familiar and calm. The familiar voices of known companions murmuring nearby before the quiet settled. These are the conditions under which human sleep evolved, and some remnant of the nervous system's evaluation of those conditions persists in us today, built into our neuroceptive system like an ancient template that we still evaluate new environments against. This is why the environment of sleep matters so viscerally, why a closed door can feel qualitatively different from an open one, why familiar sounds are less likely to wake us than unfamiliar ones, why sharing a bed with someone trusted can, for many people, allow a deeper sleep than sleeping alone, the nervous system recognizing, in the presence of another calm, trusted body, something that matches that ancient template. I am among known others. The fire is burning. The dark is full of familiar sounds. I can afford to go deeper. I am safe. The neuroceptive system is reading these cues right now in your body, in your room. Whatever arrangement of sensory information surrounds you. The temperature, the sounds, the darkness, the texture of what you are lying on, the quality of the air, the presence or absence of other people. Your nervous system is reading all of it, evaluating it against both your personal history of safety and a far older inherited template, and drawing a conclusion. And the conclusion here tonight, based on everything the nervous system is currently receiving, is that you are safe. Let us think about what safety makes possible. Not just physiologically, but in terms of the whole of a human life. We have established that safety is the precondition for the body's restorative work. For sleep, for digestion, for immune function, for cellular repair. These are the physical foundations of health, and they are all gated by the nervous system's assessment of the current situation. While the nervous system believes it is under threat, these processes are deprioritized. The moment that assessment changes, they resume. But safety is also the precondition for everything we might call flourishing. And this is where the science of safety becomes something that reaches beyond the body into the whole of what it means to be alive as a human being. Porges was explicit about this. A neuroception of safety is necessary before social engagement behaviors can occur. What he means by this is that the ventral vagal system, the system responsible for the warm, readable face, the prosodic voice, the tuned ear, the capacity for genuine connection, does not operate properly when the nervous system is in a defensive state. You cannot be fully open while you are partially on guard. You cannot listen deeply while part of your attention is monitoring for threat. You cannot be truly vulnerable while your nervous system is keeping one hand on the door. Connection, real, deep, nourishing human connection, requires safety as its precondition. Not safety as a luxury or a bonus, as a biological requirement. The nervous system will not fully permit the kind of open, unguarded presence that genuine connection requires unless it has first concluded that the current situation is safe. And when it does conclude that, when the neuroception comes back positive, when the ventral vagal state is engaged, the quality of connection that becomes possible is different in kind from the surface-level social interaction that happens in more guarded states. When two nervous systems are both in a ventral vagal state, something specific happens between them. The faces become more readable. The subtle play of muscle across a face that communicates intention and feeling becomes more active and more legible. The voices take on their fullest prosodic quality, that musical quality of inflection and rhythm that carries emotional meaning alongside the literal content of words. The listening deepens. The middle ear muscles, regulated by the ventral vagal complex, actually tune themselves more precisely to the frequency range of the human voice, making it easier to hear the other person clearly and to register the nuances of what they are communicating. Two calm nervous systems, in the presence of each other, naturally co-regulate. Each one reinforces the other's signal of safety. The effect compounds. This is why sitting in comfortable silence with someone you trust feels different from sitting alone. It is not simply the presence of another person. It is the presence of another person whose nervous system is also at rest, sending signals through their posture, their facial expression, the rhythm of their breathing, the quality of the sounds they make or do not make, that the ventral vagal system reads as "this person is safe. You can relax further." The evaluation has been completed, and the result is positive. Learning also requires safety, not just in the sense that it is easier to study when you are calm, though that is certainly true. In a deeper, more structural sense, the kind of learning that changes who you are, that shifts how you see the world, that integrates new understanding into the existing fabric of your thinking, that kind of learning requires a nervous system that is genuinely open. The prefrontal cortex, when the amygdala is quiet and the parasympathetic system is active, forms new neural connections more readily. The process of synaptic consolidation, the strengthening of neural pathways that represents the physical substrate of long-term memory, works most effectively during periods of rest and, particularly, during sleep. Memories are not simply stored when they are formed. They are continuously processed, refined, and integrated over the hours and days following the original experience, and that processing happens most completely when the nervous system is in a state of safety. Creativity, too, is a resident of the ventral vagal state, the kind of creative thinking that produces genuine novelty. The unexpected connection between distant ideas, the image that surfaces from below the level of deliberate thought, the solution that arrives whole when you have stopped trying to force it. These tend to happen not at a desk in a state of determined effort, but in the loosened, drifting, associative quality of mind that comes with genuine rest. The default mode network of the brain, which is associated with mind-wandering, imagination, and the spontaneous production of creative associations, is most active when the attentional systems are not forcing a narrow focus. It requires the kind of diffuse, open awareness that is only fully available when the threat detection systems are not claiming a share of the available bandwidth. Many of the most important insights in the history of human creativity have reportedly arrived in liminal states, in the space between waking and sleeping, in the bath, on a walk, in any of those unstructured moments when the mind is released from its directed work and allowed to wander. These are, neurologically speaking, the moments when the parasympathetic system is dominant and the prefrontal cortex, released from its task-focused mode, has access to the broader, more associative networks of the brain. Safety, it turns out, is not just where we heal. It is where we think best, where we create, where we connect most fully, where we are most richly and completely ourselves. Genuine learning, the kind that reaches into the structure of existing understanding and reorganizes it, the kind that changes how you see rather than simply adding to what you know, requires a nervous system that is not in a defensive state. Research on education has consistently found that stress impairs the acquisition and retention of new information. Not just extreme stress. Even moderate, chronic low-level stress reduces the plasticity of the prefrontal cortex, the region responsible for integrating new information with existing knowledge, for forming the complex associations that constitute genuine understanding. In safety, the prefrontal cortex operates more fully. Its connections to the rest of the brain, including its inhibitory connections to the amygdala, are stronger and more available. Thinking becomes more flexible, more creative, more capable of holding complexity without resolving it prematurely. The capacity for perspective-taking, for genuinely imagining the experience of another person, expands. The capacity for what psychologists call mentalizing, or theory of mind, improves. In safety, we become more fully ourselves, more capable of the best of what human intelligence and human connection have to offer. And healing, both physical and psychological, requires safety. The immune system cannot do its most sophisticated work while the body is in a state of sympathetic activation. The process of integrating difficult emotional experiences, making meaning of them, placing them in context, metabolizing them so that they lose their acute charge, is one that happens most effectively in states of parasympathetic rest, particularly during certain stages of sleep. The body heals in safety. The heart, in both the physiological and the metaphorical sense, heals in safety. This is why the experience of chronic unsafety, whether from an environment that is genuinely dangerous or from a nervous system that has been calibrated to perceive danger where others might not, is so costly. It is not simply unpleasant. It is physiologically expensive. It uses resources that the body would otherwise deploy toward health, connection, learning, and growth. It keeps the body's maintenance systems running at reduced capacity indefinitely. Over long periods of time, the accumulation of that expense shows up as illness, as exhaustion, as difficulty forming and maintaining the connections that make life worth living. Understanding this is not meant to create anxiety. Quite the opposite. It is meant to illuminate the profound importance of the moments of safety, even brief ones, even imperfect ones, that punctuate ordinary life. Every time the nervous system successfully registers safety, something in the body is repaired or strengthened. Every time the amygdala quiets and the vagus nerve carries its calming signal, the immune system gets a moment to do its work more fully. Every good night of sleep is the glymphatic system, the brain's remarkable cleaning and maintenance apparatus, discovered only in 2012, doing its extraordinary work of flushing metabolic waste from between the neurons, including the misfolded proteins that have been associated with neurodegenerative conditions. The glymphatic system runs most actively during deep, slow-wave sleep, during the same stages of sleep that require the nervous system to be genuinely at rest to reach. During wakefulness, the interstitial space between brain cells contracts, and glymphatic flow is reduced to perhaps 10% of its sleep state activity. During deep sleep, that interstitial space expands by 60% in some measurements, and cerebrospinal fluid rushes through the brain's perivascular channels, sweeping metabolic debris out of the neural tissue and delivering it toward the meningeal lymphatic vessels that drain it out of the brain entirely. This extraordinary process of nocturnal brain maintenance requires, as its precondition, the same thing that everything else in this story requires: safety. Safety, then, is not the destination of a healthy life. It is the ground upon which a healthy life is built. It is not the thing you achieve after you have handled everything else. It is the thing that makes handling everything else possible. There is one more layer to add before we arrive at the close of this evening's story. It is about memory and time and the particular quality of presence that safety makes available. We have talked about how the nervous system in a defensive state narrows its attention. It focuses on the source of potential threat. It filters out everything that is not relevant to the immediate evaluation of danger. The peripheral is dropped. The detail is lost. The whole of the available sensory world is compressed into a searchlight aimed at whatever might require a response. There is a corresponding change in the experience of time. When the nervous system is activated, time compresses. The present moment becomes very loud. The recent past and the immediate future crowd in around it. Long-term perspective becomes difficult. The ability to hold the larger context, to remember that this current difficulty is one chapter in a longer story, that this feeling will pass as other feelings have passed, diminishes. Threat narrows not just attention but temporal horizon. In a state of safety, time expands. The horizon of what is available to the mind becomes wider. The past can be visited without the urgency of re-experiencing its most charged moments. The future can be contemplated with something closer to equanimity, as a space of possibility rather than a territory of anticipated danger. And the present moment opens up in a way that is hard to describe but easy to recognize. It becomes more spacious, more textured, more fully habitable. You can notice more. The exact quality of darkness on the other side of your eyelids. The temperature of the air at the edge of the blanket. The small sounds of the house or the building or the street, all layered on top of each other in their particular arrangement. The weight of your own body distributed across whatever is supporting it. The specific feeling of being in this particular body, on this particular night, in this particular room that is yours. The present moment in safety is not something to get through. It is somewhere to be. This expansion of presence is not metaphorical. It corresponds to measurable changes in brain activity, to the recruitment of brain regions associated with interoception, the awareness of the body's internal state, to the quieting of the default mode network's more anxious, ruminative activity, to the increased availability of the prefrontal cortex for the sustained, open kind of attention that allows us to be genuinely here. And here is something that I think is worth sitting with as this evening grows quieter around you. The moments we remember most vividly, most warmly, most with the sense that they were real, they tend to be safe moments. Not the most exciting moments. Not necessarily the happiest moments in the conventional sense, but moments of genuine safety. The particular quality of a Tuesday evening in a place you loved. The feeling of being held. The sound of rain on a specific window on a specific night when you were young and everything was, for just a few hours, entirely all right. These memories stick because they were inhabited. Because the nervous system was fully present in them, not filtering and narrowing and preparing. Because you were there. Safety is, among other things, where the most real experiences happen. The ones that stay. Let us take a moment, before we bring this evening to its close, to think about something that might be the most important implication of everything we have covered. We have talked about what safety does to the body in the short term, the slowing heart, the deepening breath, the softening muscle, the resuming digestive system. But safety also does things to the body over the long term, in ways that accumulate across months and years and decades, and these longer-term effects are, if anything, even more significant. The stress hormone cortisol is at the center of this longer story. Cortisol is produced by the adrenal glands, which sit just above the kidneys, in response to activation of the HPA axis. The hypothalamic pituitary adrenal axis, the hormonal cascade through which the brain's appraisal of threat is converted into a biochemical response that reaches every cell in the body. In the short term, cortisol is genuinely useful. It mobilizes glucose, preparing the body for action. It modulates the immune response, temporarily enhancing certain aspects of immunity while suppressing others. It sharpens attention and enhances the consolidation of emotionally significant memories. A brief spike of cortisol in response to a genuine challenge is entirely appropriate and entirely healthy. But cortisol in chronic elevation, the kind that accumulates when the nervous system is spending too much time in sympathetic activation, when the threat detection system is running at a low but persistent level that never fully resolves, is a different matter entirely. Chronically elevated cortisol is one of the most thoroughly studied contributors to long-term health decline in humans. Its effects are systemic, touching virtually every organ system in the body. On the immune system, chronic cortisol elevation produces what researchers have called cortisol resistance, a state in which immune cells, having been chronically exposed to high cortisol, become less responsive to its regulatory signals. Under normal conditions, cortisol helps terminate immune responses once they have served their purpose, preventing the inflammation from continuing past the point of usefulness. When cells become resistant to this regulatory signal, inflammation becomes chronic and diffuse. The body's immune system, no longer properly regulated, begins to produce inflammatory cytokines at elevated baseline levels, contributing to a state of low-grade systemic inflammation that has been linked to cardiovascular disease, metabolic disorders, mood disorders, and accelerated biological aging. On the brain itself, prolonged cortisol elevation has been shown to reduce neurogenesis. The formation of new neurons in the hippocampus, which is the brain region primarily responsible for the formation of new memories and for spatial navigation. The hippocampus is one of the regions most sensitive to glucocorticoid stress hormones, with high densities of cortisol receptors that make it particularly vulnerable to chronic exposure. Research has shown that people with conditions involving chronic stress or cortisol dysregulation often show reduced hippocampal volume, with corresponding effects on memory function. This is one of the biological pathways through which chronic stress impairs the capacity to form and retain new memories, not as a psychological consequence of preoccupation, but as a direct structural consequence of the chemical environment that chronic stress produces in the brain. There is also the telomere story. Telomeres are the protective caps at the ends of chromosomes, structures that function something like the plastic tips at the ends of shoelaces, preventing the chromosome from fraying and degrading. With each cell division, telomeres shorten slightly. When they become too short, the cell can no longer divide normally and begins to malfunction or die. Telomere length is, in a very real sense, a measure of cellular age, or more precisely, of the rate at which a cell has been aging relative to chronological time. And researchers have found that chronic psychological stress is associated with shorter telomere length, even after controlling for other factors. The immunological effects of chronic stress appear to accelerate cellular aging in measurable, physical ways. What this means is that the body keeps a kind of account of how much time it has spent in a state of vigilance versus a state of safety, and that account is written in the cells themselves. Every hour of genuine rest, every night of restorative sleep, every moment in which the nervous system successfully registered safety and allowed the parasympathetic state to fully engage. All of these are deposits into a cellular account of health and resilience that accumulates over a lifetime. This is not meant to generate anxiety about the periods when rest was difficult or safety was hard to find. It is meant to illuminate the genuine, physiological value of what is happening right now. Each moment of safety is not trivial. Each moment of genuine, body-level rest is not merely pleasant. It is contributing in specific and measurable ways to the health of every cell in the body. It is giving the immune system time to calibrate. It is giving the hippocampus time to generate new neurons. It is giving the telomeres time to be maintained. It is giving the body the conditions it needs to do the work that only safety permits. And sleep, the deep sleep toward which you may be moving right now, is perhaps the most powerful version of this. We know from research on the glymphatic system that the brain's cellular cleanup, which depends on the interstitial space between neurons expanding to allow cerebrospinal fluid to flow freely through the tissue, happens primarily during slow-wave sleep. During wakefulness, that interstitial space is compressed, reduced to about 13 to 15% of total brain volume. During deep sleep, it expands to 22 to 24%, dramatically increasing the volume available for fluid flow and waste clearance. The difference is not marginal. It is a nearly 60% expansion of the cleaning space. The waste that is cleared includes metabolic byproducts of neural activity, the molecular debris that accumulates as neurons do their daytime work of processing information, forming memories, regulating emotion, and maintaining consciousness. Some of this debris, if not cleared, aggregates into the misfolded protein clusters, amyloid beta and tau, that are associated with neurodegenerative conditions. The glymphatic system, working most efficiently in deep sleep, clears this debris before it has the chance to accumulate to damaging levels. But the glymphatic system requires that the nervous system be genuinely at rest. Not just in a light sleep from which you could be easily roused, but in the deeper, slower wave stages of sleep that are specifically produced by a nervous system that has made the determination, at the level of neuroception below conscious awareness, that the environment is safe enough to allow the body's defenses to stand down. Sleep deprivation and poor quality sleep and fragmented sleep, all of these impair glymphatic function. A study tracking amyloid beta levels in the brains of healthy volunteers found that even a single night of sleep deprivation increased amyloid beta accumulation in the brain by detectable amounts. One night, and the regions where accumulation was greatest were the hippocampus and the thalamus, regions known to be closely involved in learning, memory, and the regulation of sleep itself. The brain, deprived of its nightly cleaning, begins to accumulate the material that its cleaning system would otherwise have removed. All of this has an implication that is both humbling and, in the quiet of this particular night, somehow comforting. You are not here simply passing time until morning. The hours you spend in sleep are doing something specific and essential. The brain is being maintained. The cells of the body are being repaired. The immune system is being calibrated. The emotional memories of the day are being processed and integrated, their most acute edges gently worn smooth by the particular alchemy of REM sleep. There is research on this that I find quietly remarkable. The neuroscientist Matthew Walker and colleagues studying sleep and emotional memory found that REM sleep appears to selectively process emotionally charged memories in a way that preserves the informational content. What happened, who was there, what the sequence of events was, while gradually reducing the emotional activation associated with recalling it. The same memory that felt sharp and difficult in the evening has, after a night of good REM sleep, the same factual content but a slightly reduced emotional charge. This process, which Walker's research describes as overnight therapy of a kind, requires the particular neurochemical environment of REM sleep. Specifically, the reduced activity of noradrenaline, the stress-related neurochemical that during waking makes emotional memories feel vivid and activated. In REM sleep, noradrenaline quiets, and in that quieting, the brain can replay and process emotionally significant experiences without re-traumatizing itself. The nervous system, having done its nightly work in the safety of sleep, wakes a little freer. The nervous system is being restored to the baseline state from which tomorrow's living will begin. All of this and everything else depends on the same simple thing. The same thing that everything in this evening's story has circled back to. The same thing that your nervous system, right now in this room, is quietly, patiently trying to find its way toward. Safety. Not safety as a concept. Safety as a state, as a physiology, as the specific, lived, body-based condition in which the amygdala quiets, the vagus nerve speaks, the breath deepens, the muscles release, the gut resumes its work, and the brain, receiving all of this upward through the nerve that wanders from brainstem to heart to belly, concludes. We can rest now. We can do the deep work now. We can be genuinely, fully, restoratively here. We have traveled far tonight. We started with the body in a room, and we went backward through 500 million years of evolutionary history to understand what the nervous system is, and why it works the way it does, and what it is doing in the moments when it finally decides that everything is all right. We have met the amygdala and understood its speed and its ancient wisdom. We have met the vagus nerve and followed its wandering path through the body and understood the bidirectional conversation it is always having between the brain and the heart and the gut and the lungs. We have encountered neuroception, the nervous system's preconscious, prelinguistic reading of the room, and understood that what your body knows before your mind has caught up is real information, even if you can never fully access the process by which it was gathered. We have sat inside the physiology of safety. The slowing heart, the deepening breath, the softening muscle, the resuming gut, the falling cortisol, the rising oxytocin, the quieting amygdala. We have understood why all of this is not a luxury but a necessity, the foundation upon which everything else, every form of health and healing and connection and learning and growth, depends. And we have arrived here, at the close of a night that is simply a night, moving at its own pace, carrying its own particular quality of dark and quiet, not requiring anything of you. I want to leave you with something simple, not a technique or a practice or a list of things to remember, just a thought or less than a thought, an orientation. There is a kind of misunderstanding that many of us carry about the relationship between calm and effort. We believe somewhere beneath our official opinions about things that feeling safe requires doing something, that it is a destination we have to travel to, a condition we have to construct, a state we have to earn through some combination of problem solving and worry management and sufficient caution. We spend a great deal of energy trying to feel safe by thinking our way to it, by resolving every worry, anticipating every risk, covering every contingency until finally, if we have done enough, safety might be permitted to arrive. But the neuroscience tells a different story. The threat detection systems of the nervous system, the amygdala, the sympathetic nervous system, the HPA axis, and its cortisol cascade, these systems are the exception. They activate in response to specific inputs that match threat criteria. When those inputs are absent, these systems do not have to be manually turned off. They simply are not turned on. The baseline, the default state toward which the body continuously tends, is rest, is safety, is the parasympathetic state of the vagus nerve doing its quiet, calming work across all the organs of the body. What this means is that the work of finding safety is not adding something. It is not constructing something from nothing. It is, more often than not, the removal of whatever has been activating the alarm. The noise, the light, the worry, the unresolved conflict, the physical tension that feeds back up through the vagus nerve as a signal of distress. When those activating inputs are removed or quieted, the nervous system does not need to be convinced to rest. It moves toward rest naturally, steadily, with the quiet persistence of water finding its level. This is what is happening right now. Nothing dramatic, nothing effortful. The room around you is doing its part. It's quiet, it's dark, it's familiar sounds, it's temperature. The body is doing its part. The breath that has probably slowed without your noticing, the jaw that has probably released a little, the weight of the limbs that has probably become more noticeable as the muscles give up their holding. The nervous system is doing its part. Reading all of this, updating its assessment, moving its evaluation steadily in one direction. You do not have to manufacture safety. You do not have to earn it or deserve it or construct it from scratch in each new moment. Safety is the state your nervous system is always moving toward, whenever conditions permit. It is not an exception to the normal order of things. It is, in a very real biological sense, the default, the state the body returns to when there is nothing actively pulling it away. What you are experiencing right now, the weight, the warmth, the slowing, the softening, is the body doing what it evolved to do. Coming back, settling, resuming the quiet work it saves for exactly this. The glymphatic cleaning cycle of the brain is beginning, cerebrospinal fluid moving through the channels between neurons, sweeping metabolic waste outward and away. The immune system, no longer competing with the resource demands of sympathetic activation, is doing a more thorough survey of its domain. The endocrine system is releasing the growth hormone that signals tissues to repair themselves. Every cell in the body, given the green light of safety, is turning its attention to the longer-term investments of maintenance and resilience that it was putting off while the nervous system was still in any degree of vigilance. This is what rest actually is. Not an absence of activity, but a different kind of activity, the quieter kind, the patient kind, the kind that the body only does when it trusts that the moment is safe enough to do it. Your amygdala is still listening. It always will be. But right now, what it is hearing is a room that is simply a room. A night that is simply a night. Sounds that are familiar. A temperature that is right. And around you or inside you, something old and vast and patient recognizing all of this is safe. Your vagus nerve is carrying the signal. Downward to the heart, slow. To the lungs, deepen. To the gut, resume. To the muscles, release. And upward, back up through all those fibers that carry the body's news to the brain. The message that the body is in a condition consistent with rest. That the evaluation is complete. that the coast is clear. You are somewhere specific. In a room, in a building, in a city or a field or somewhere between them, on a planet that is spinning, as it always is without any help from you. You are lying down. You are breathing. Your heart is beating. The dark is familiar. You do not have to do anything else. The nervous system will take it from here. It knows exactly what to do. And it has been waiting patiently, reliably, with a patience that is 500 million years old, for exactly this permission. Good night. If you found something in tonight's exploration that settled something in you, some piece of science that made the experience of calm feel a little more real, a little more solid, a little more yours, I hope you will share this with someone who might need it. And if you want to keep coming here, to this quiet place where neuroscience and rest meet in the dark, where we look closely at the biology of what it means to be a living creature trying to find peace, subscribe to Deep Science Sleep. There are more nights like this one, more journeys into the science of what happens when the world goes quiet and the body finally gets to do what it has always known how to do. Thank you for being here. Sleep well.